Welcome back to Further Solutions Academy. Further Solutions Academy. Kindly share and subscribe if you have not subscribed before. Do that, and after watching the video, make sure you drop your comments. And also, if you want to reach us, you want to book for our online class, you can comment below, or you make use of this line. With this line, you can call us, you can WhatsApp us, and also via Telegram is allowed. Now, I'll be walking you on the triangle of forces. Triangle of forces. Now, what am I trying to talk about? When you have a point and you are having three, this is a point. You have something like this acting upon the point. This is the point we are talking about. We have the force, we have a tension, and we have a weight. Now, this is what I mean by what? Triangular. Now, let me try to state some things for you to understand and show some example, practical example. Now, look at this. Now, look at this. Okay, look at this. The principle of triangle of forces is applied to solve problems in which three forces act on a body. Okay, back to my explanation. The principle of triangle and of a force is applied to solve problem in which three forces act on a body to keep it equilibrium, which is what I've explained earlier. It states that when a body is in equilibrium under the action of three forces, the three forces can be represented in magnitude and in direction by the three sides of a triangle taken in order. Now, look at the tension, look at the force, and look at the weight. That is what I'm trying to explain. Now, when it means there are three points connected to a point, and that is an equilibrium, or that is what makes it. Now, let me try to make example on this regard for you to understand what I'm trying to explain. Now, look at this problem. Now, look at this simple problem. Okay, look at this question. It's a very simple question. The body P showing in the diagram below is in equilibrium if the mass of the body is, this is the mass of the body, which is 10 kg. Calculate the tension in the spring, which is taking your gravity as 10 meters per second. Now, how do I solve this thing? Let's solve this problem together. It's a very simple problem. Now, don't forget my weight, which is very, very important. It will be 10 multiplied by 10, which is equals to it will be equals to 100 Newton. Take note of that. That is my weight. Now, weight of the body P acts downward. It acts downward, and don't forget that the force acts in the horizontal direction. Which what I'm trying to do is F. This is going to be my F. Okay, this will be my F. F acts in the horizontal direction. Now, it means indirectly, I'm talking about something like this. This will be 60 degrees, and I have my F, which is my force, and this should be my weight, which is 100 Newton. Now, that is what I am trying to explain in that area. Now, since I have that, I cannot continue by having, since I have that, I cannot continue by having, what can I do to make this normal? You have to think of what to do. Now, with this, I can try to form by taking the magnitude, direction, and the direction on each force in sequence order. Now, what am I going to try to do is that I can try as well to do it this way. Have something like this. Call this place a tension. which the tension is already is what I'm looking towards, which is going to be my T, and I'll be having the weights. The weight also, this is the weight. This is going to be my weight, which is going to be 100 Newton. I think we are told it's 100 Newton. Now, since I have that as 100 Newton, I can now have my force. My force will move in this direction. It will move in this direction. Now, my weight is also, my force is also not given. Now, with what is on ground, this should be the 60 degree we are talking about. Now, I can now go to, we have what's called Lamy's theorem. I think I've worked on it one of our video, but at this point, I'm just going to trigonometry ratio, which I'll be having, this should be the opposite and adjacent. Now, with this now, I can now say that, okay, what can I do? What next should I do? Now, here is my 90. Now, how do I solve this type of problem? Now, it means I can say that this will be my opposite. This will be my opposite. This will be my adjacent. Now, I cannot easily say that what can I do to make this real is that okay, now it means I can call this place apply force, which is going to be F I'm referring to. Now I can now say that my tan 60 will be equals to my F all over 100. My F all over 100. Okay. Now, since I have this, it means I will be, oh, no, sorry, I can't use cos. I can't use tan, it will be cos I'll be using. Now, if I have this, it means I will be talking about my cos 60 will be equals to adjacent 100 all over tension. Now, this is going to be T, this is applied forces. It means I can say that my T will be equals to 100 all over cos 60. Now, we all know that cos 60 is 0.5, which I will be having 100 all over is 0.5, which it will be equals to 200 Newton. That is 200 Newton. That is what I need to, that's all. That is all what I have. It means it's 200 Newton. Now, let me try to show another example on. Okay, look at this. Okay, look at this problem also. That will really help us to. Now, look at this problem. It's a very simple one. Let's try to work it out. You have to determine the magnitude of T1, which is going to be here, which is very simple. Now, how do I resolve this to triangle? Very important. It's a 3-point, and the first thing you need to do is that this is your weight. Now, I can resolve by having my weight in this form. This should be my weight, which I'll be having 100 Newton. Now, since I have my weight as 100 Newton, the next thing I will be having, I'm trying to resolve something. This will be my applied force, which is going to be my T1, which is unknown. It's not given to me. Now, it means since I have that, don't forget that there will be 30 here. Sorry, let me give a 30 degree here. Now, since I have that, it means I'll be having the force on this part, moving on to this, which is going to be the tension T2, which is going to be force. Now, by so doing that, successfully add my triangle, which is trigonometry ratio will be of L. Now, trigonometry ratio will be of what? Of L. Since I have this, what can I do? Now, don't forget my 30 degree will be around here. Now, since my 30 degree is around here, because I just, what I'm having here, I just bring it down. And that's what I'm trying to do. That is nothing just like that. And this become my T1. And by so doing that, I just lifted the function. Now, since I have this, I can now run towards I'm looking for my T1. My T1 will now be what? Tan 30 degree will be equals to, we have T1 all over 100, which is, I'm trying to work on 12 of the SOHCAHTOA. Now, since I have this, it means my tan T1 equals to 100 multiplied by tan 30 degree. Now, my tan 30 degree, we all know what is 30 degree, which is going to be 3, which I have that as, when you use a calculator, I will have 57.74 Newton. That is my final answer. Now, before I end this, can you see it's very simple, very, very straightforward. Before I end this, let me try to show another technical problem, that really, it will really help us, to really help us to understand triangular force very well. Now look at this question. It's also a simple question. One has to find the value in the T. Find the value in the T. A 10 Newton, B 11.8 Newton, C 20.0 Newton, and D 40.0 Newton. These are very simple questions. The first thing we need to do is that we have to resolve it. Very, very important. Now, if I were you, I will try as much as possible to resolve. Now, it means I can say that I have the tension this way, and is just the weight is 20 Newton. Now, I have, if I should resolve this 20 Newton, it means take away 90 from 30, it will be 60. Here will be 60 Newton. Now, I've taken away that from that, and this will be the tension. And also, I have something like this. Take away 30 from 90, it will be 60 degree. Now, 60 also, here will be 60. By so doing that, I've successfully, that is all about that. That is all about it. Please, the direction is very, very important, because this is just like we are talking about vector. Now, it means with this, I have T. I have T. Now, what I need to do is that I need to go on sine rule. Sine rule. We all know sine rule to find T, just to find T. Now, I can go on sine rule by having 20 divided by sine 60 equals to T divided by sine 60. Now, normally, this will cancel this. That is all about that, yes? That is very allowed, yes. It means my T will be equals to 20 Newton. Now, it means the whole side, I don't need to solve much problem, because it's a very simple question. Since the angles are the same, it means the all side are what? Are the same, which is also equals to T2, which is equals to what? 20 Newton. It means my answer is C. That is my answer. Now, can you see how simple it is? Now, let me, before I end this triangle of forces, let me try to show another last example on it. Now, look at this problem. It's a very simple one also. You are asked to calculate the magnitude of T2. This is T2. Now, what you just need to do is that solution, you have to resolve it. How do I resolve it? Now, if I bring down all what I'm having, just bring it there. I wish you can understand what I'm saying. Like by having Okay, if I were you, I can turn this to this is 30. I can bring, that's what I'm trying to say. Can you see what I'm trying to say? And I have this. It means in resolving, this one become T2. Here will remain your T1. And I move on. This one will be your what? Your weight. Please take note of what I'm doing now. It's very, very simple. I think by so doing that, I have resolved it back to where I want it to be, which is triangle. Indirectly, I'll be having something like this, something like this, something like this. Now, which I will be having this as 30 degrees. Don't forget, we are talking about what? Force in this direction. Please, there must be a direction on it, which is, can you imagine? Now, here will become 250 Newton. And here become your T2, your T1, and you go. It means I will move on to your 30 also. We have time. 30 will be equals to T2 divided by 250. Now, by having this, my T2 will be equals to 250 multiplied by tan 30. Now, which I'll be having 250 multiplied by 0.577. Now, which I will be having 144.34 Newton. That is my T2. Now, can you see? That is all about that. Now, I'm just showing you the easiest way, with the help of the diagram given unto me, just to, that is all about that. You can see triangular force is very simple. Don't forget to share this video, subscribe for Further Solutions Academy. Thanks for watching.